So I'd like to give you a little bit of guidance and introduction into this assignment that you're going to be doing on practicing. You're describing your data and kind of look at some of the things we're going to be looking for as we go through this. Plus, the warm up that is on this has quite a bit, is quite involved. Okay. In fact, some of this we may kind of do together in class, but let's go ahead and take a look at some of these items. Now, first of all, there is a computer printout that we have right here. So I want to kind of go through a couple of things on this computer printout. So we have these variables, the female rate and the male rate of whatever the context is here. So it didn't quite talk about that. Now, this N tells you how many pieces of data there are in the data set. Of course, here is the mean and the median. This here is called trimmed mean. And so we are not ever interested in what that trimmed mean is. And then of course here you can see here's the standard deviation. Okay, so that we will be using because if we use the standard deviation rule, of course, there's standard deviation. Now, this is a standard error of the mean, not something we are going to be using at all this year. Okay, in AP we do. Now look here, here's your minimum. So you have the minimum for the male and the female, the maximum for the male and the female, the Q1 and the Q3. So this Q1 and Q3, of course, is going to be needed to get the IQR because in order for you to get the IQR, or you're going to need that IQR, that Q1 minus your Q3, because you're going to need to compute that. So you're going to end up getting a value for the female IQR that you're going to want to compute. So that you can do the fences, okay? Because down here I say compute with the IQR rule, compute with the standard deviation rule, okay? So you're going to want to have to compute this female rate fence and the male fence. Okay, now, so what we would need to do here for our female rate IQR rule is, of course, I'll just kind of start you off here. You got to know those formulas. So for the upper fence, that is your Q3 plus your 1.5 times the IQR. Hence, that's why you got to compute that over here. And then, of course, for your lower fence, you're going to do your Q1 minus 1.5 times the IQR. Now, then, of course, you will be using these female numbers when you do these fences here. You got your Q1, your Q3, and your IQR. And so that's what you will do to get that female fences. Okay. And remember that when you do that, then you want to look at, say, the minimum. And you want to see so this is the question you're asking. Is the minimum below that lower fence? Okay, because if that minimum is below the lower fence, then you have a lower outlier. And then for the upper area, you're looking, is the maximum above the upper fence? Okay, and so then if it is, then you're going to be having an upper outlier. Okay, so now let's talk that standard deviation rule. So on standard deviation rule, you're going to have to be using this mean and standard deviation. Okay, because of course, for our upper fence, that's going to be our mean plus 2 standard deviations. Okay, and then again, you're going to see is the maximum above the upper fence. Okay, so what's interesting thing that we're going to find out is that there are some times, and it doesn't happen very often, but it is interesting that sometimes you might have an outlier with the standard deviation rule, but not the IQR rule, or vice versa. Okay, so it's interesting to take a look at both of these kinds of rules and see if there's a discrepancy. But anyway, this is kind of just outlier fence practice. So, of course, your lower outlier fence with the standard deviation rule is your mean minus 2 standard deviations. Okay, and then you're seeing is the minimum below the lower fence. Okay, and that's how you're determining that. And so then that's how you know if you have any lower outliers or upper outliers and so on. Then you will do this process again with the male data. So you'll look up there in that computer printout for the male information rather than the female information. All right. Now, the other main concept that this assignment takes into consideration is that relationship between shape and the relationship between mean and median. Okay, so what we want to do is recall that back here on this page, whatever this is, page 14. Okay, so back here on page 14, we remember that if we had a shape that was skewed to the left, like this right here, then our mean was less than the median. Now, mode is in there as well, but we typically don't see that criteria in our information. If the data is somewhat symmetric, then our mean is going to be pretty close to that median. It's usually within 1, maybe 2 points, okay? And that how close it is really kind of depends on, how big this data is. Is this from 0 to a million? Okay, then them being pretty close to each other might even be 100 apart from each other. All right, skewed right. Of course, that's our shapes that are skewed to the right. So then in those cases, the mean is greater than the median. So that is what is playing into some of these other answers. So here we're going to consider the shape of the distribution of salaries of NFL players, and that's going to play into our decision of which of these numbers is the mean and which of these numbers is the median. Also, look here at this stem plot. If you turn your head sideways and you look at this, then you can see really the shape of that distribution from least to greatest, and then you have an idea of that relationship between mean and median. Okay, so again, that's what quite a bit of these questions are hinged upon. Okay. Then we also will have some questions asking us about the benefits, the disadvantages, and the disadvantages of the stem plots, okay, and the dot plots and the histograms. So we want to kind of recall what those things look like. So let's do that just real quick. See, for histograms, we do not see individual pieces of data. Okay. With stem plots, here's a stem and leaf plot, and you are able to see what the individual pieces of data are. Also, for a dot plot, you would have like 61, 62, 63, 64, 65, 66. So, in essence, you actually can tell what the individual pieces of data are on the dot plots as well. Okay. Let's see. And then we have this is going to be a warm up for your quiz that you're going to be having next class. So look, I'm going to throw this practice of making a box plot in here to you again. Scale, box, fences, whiskers, scale, box, fences, whiskers. Okay. And here describing, putting in the correct shape and the mode. Remember that uniform here is when you have no modes. Okay, uniform is when you have no modes. Okay, and this is a real interesting piece. And so I think actually I'm going to take a moment I'm going to do a little separate video on some of this starting with some of this information here because it's got some interesting components to it. So let me just kind of stop and make a separate little video to walk you through some of the ideas involved in understanding the relationship between data set and their histograms.